This presentation is part of the Growing a New Generation of Illinois Fruit and Vegetable Farmer program. It covers composting on the farms in Illinois. My name is Ellen Phillips, and I'm a retired extension educator. Today we are looking at what compost is. We'll also cover the rules and regs for Illinois you need to be aware of. Next, we'll get into the overview of the different methods of composting from small to large-scale systems. Then we'll look at the key factors that are needed to be monitored in order to have good quality compost. Lastly, we'll look at some of the ways to use compost. The Soil Science Society of America defines compost as any organic materials that are put into a pile of some sort, mixed together with some moisture, and then it goes through a composting process to become a soil amendment. Composting, then, is the process by which those organic materials are decomposed into a soil amendment. Today we'll be talking about the key components needed to speed up decomposition within a composting process. Why even go to the effort of composting? Because it is a lot of effort to do it well. There are many benefits of the soil amendment for improving soil quality. Compost can increase the amount and strength of soil aggregates that result in an increase in soil porosity. This directly impacts the ability of the soil for water infiltration and increased water holding capacity. Compost also increases the cation exchange capacity that allows more nutrients to be held. The composting process depends on a wide variety of soil microbes, which results in soil amendments being alive with an active biological community. Depending on the organic materials that are put into the pile, compost can actually modify the pH to be more neutral. There's quite a bit of research also demonstrating the benefits of compost in suppressing plant diseases. Let's look at the rules and regulations you need to know about in order to compost in Illinois. Municipalities and towns may have individual rules regarding whether or not they even allow composting, or they might have very specific rules about the location or types of composting bins allowed. They may also have specific information about things that are allowed to be put into the compost pile. Oftentimes, things like food scraps, particularly meat and dairy, are not allowed. Check with your local town or municipality for the regulations. In Illinois, there are specific rules if you're going to do large-scale composting. Composting permits are normally required by the Illinois EPA for large-scale composting operations. However, if you're composting on a farm, there are some exemptions. You may have a large-scale composting facility on your farm if you do not bring in anything from the outside of the farm, such as leaves or manure from a neighboring farm. The farm must also be producing crops on an annual basis, and the compost site must be operated by the farmer. Before starting a large-scale composting operation, check with your county, as well as the Illinois EPA and the Illinois Department of Ag for specific regulations that would affect the manner in which you're going to compost. This is an example of Chicago's websites, where different levels of composting have different ordinances that apply to them, from small-scale backyard composting to large composting operations. If you're an organic farmer, compost is an excellent way to improve soil quality. There are specific rules for compost within the national standards in order to be in compliance, and these are listed here. There are specific rules regarding the type of materials that can go into a compost pile. Today, we'll be talking mainly about windrow systems, so let me point out the bottom, where it states that a windrow system must maintain a temperature between 131 degrees Fahrenheit and 170 degrees Fahrenheit for 15 days. During the time of composting, the materials must also be turned a minimum of 5 times in order to meet the minimum standards. In 2010, additional guidelines were submitted And those guidelines state that the compost materials are a little bit more flexible in what is allowed. What is most important is that the manure that is used in compost piles is not required to come from an organic source. In Illinois, there are rules regarding the application of compost to soils. There are no setback areas on the field application, but there is a maximum rate of 20 tons per acre per year. If you think you need to apply more than that, it is possible to apply for an exemption from the Illinois EPA. There are many different ways to compost. How you compost depends on your farm, the organic materials available, and your potential use for that compost. The National Organic Standards 2010 Amendment does allow vermicomposting and has some guidelines on how to do this. Vermicomposting is produced by using red wiggler worms to do the decomposition of the organic materials. One benefit of vermicomposting is that it can be done indoors and on a small to very large scale. In-vessel composting is a rapid method to compost that utilizes some kind of mechanism to continually turn the compost, thus speeding up the decomposition process. The main advantage is a very small footprint of the farm and a quick turnaround time. The main drawback is the cost of the equipment and potential for setting it up. Passive aerated windrow systems are static piles with tubing below it that mechanically move air through the pile. The air can be blown into the tube and move up through the pile, demonstrated by the red arrows, or you can use a vacuum to suction the air from the outside down through the pile. The main advantage of this pile system is that the pile does not have to be turned or moved. The main disadvantage are that the piles can dry out very quickly, so moisture has to be monitored closely. In addition, the outside of the pile may not be turned, and as a result may not be hot composted, and could potentially still have pathogens or weed seeds if not done correctly. Piles and windrows are the most common composting systems. Composting bins work well for small-scale composting and should be about a cubic yard in size. Windrows are basically long compost piles. The size depends on the equipment available to use in order to turn them. A front-end loader or a skid loader work well to turn smaller piles. Very large compost turning machines can be used on very large-scale multiple windrow sites. The main advantage of these systems are that the piles are turned regularly, so the compost is usually good quality throughout the whole system. The main disadvantage is that the piles do have to be turned regularly, and that is a lot of labor and usually requires machinery. There are several factors that must be monitored to create good quality compost. Today we're focusing on pile or windrow composting systems and the key factors that help make great compost. There is a difference between a rotting pile of organic materials and composting. Composting requires monitoring the conditions in the pile to maintain optimum conditions for microbes so that decomposition can occur. The focus of the composting system is to keep the microbes happy that are decomposing the organic materials. These microbes include bacteria, which are the primary decomposers and create the heat within the pile, fungi that are also decomposers, especially of woody materials. And there are multitudes of other creatures, from amoebas to insects to earthworms. What microbes have in common is that they must have water, because they live in a film of water around all the pieces of material in the pile. It's also their source of food that they have to have in order to live. They need a right balance of carbon and nitrogen. But lastly, they need air. Give them all of these things and they will multiply and very quickly decompose the organic materials that you have placed in the pile. Passive composting, otherwise known as inactive or cold composting, requires the least amount of attention once the pile is created. The right types of organic materials in the correct amounts are placed into the pile. It may heat up, but if it is not turned, it may not decompose quickly. If it is not turned, it may go anaerobic and different organisms take over, possibly causing it to smell. Since it is not turned regularly, this composting method does not meet organic standards. To cold compost well, try to watch what materials are placed into the pile, turn it every so often, and expect compost to be finished in about a year. For compost to be created quickly within a couple months, as well as to meet the organic standards, it needs to be actively hot composted. This requires paying close attention to several factors, including those listed here, which we will discuss individually. There are many resources to learn how to compost. Many are listed at the end of this presentation. Two that I want to highlight are the publication, The Art and Science of Composting, from the University of Wisconsin, which gives a nice overview of the composting process. If you want some hands-on experience at building and monitoring piles, plan to attend the Midwest Extension Composting School. It's offered somewhere in the Midwest every year. The composting process is actually fairly simple. Take organic materials, add some microbes by adding some soil, keep it moist to provide a home for the microbes. The microbes then create the heat that helps to kill the weed seeds and pathogens. The result is a soil amendment rich in organic matter that improves soils and readily makes plants nutrients available. Creating quality compost requires regular monitoring of some factors such as moisture and temperatures. Therefore, some record keeping is important. Record keeping is essential in order to meet the organic standards. Items should be recorded are the materials that were added to the compost recipe, regular monitoring of temperature, moisture, and oxygen, when and how it was turned, how long it was cured, and the methods used to analyze the quality of the compost. When creating compost, the size of the pile does matter. Depending on the amount of the materials, a bin may or may not be needed. For small-scale composting, or if the compost must be contained, a bin can be created out of simple materials similar to those shown in the pictures on the right. On farm, you can choose to simply form piles or windrows of organic materials. This makes it easier to turn with the equipment. The normal recommendation is that the pile be a cubic yard in size for small composting. This allows the air to flow through the pile with convection forces. The pile can be larger if it can be turned on a regular basis to incorporate air. The compost pile does not have to be covered. However, a tarp can really help control the moisture content during the wet spring or in a dry summer. Most of the times it does not have to be on a slab, but some municipalities may require that. It's also good to have it close to a water source, since you will probably have to add some water, especially during the summer. There typically are not restrictions as to where the compost pile can be placed on your property, but check with your town or county to determine the rules. Things like a high water table or being close to a lake or stream and possible runoff should be a concern. Keep in mind that large equipment like a tractor may need access and will need to turn around to move materials. In addition, during a wet spring, they might need a firm surface in order to travel to get to the compost pile. Shade is not a concern, since the heat of the pile is created by the microbes and not the sun. Microbes need to eat, so the carbon to nitrogen ratio of organic materials is important. Compost microbes use carbon as their energy source and nitrogen to build protein to multiply. A ratio of 30 carbon to 1 nitrogen is needed for optimum growth. In large-scale composting systems, having compost recipe close to this ratio is important for a quick heating of the pile. The two sources listed give some insights onto how to build these recipes out of the organic materials you have to make sure you have the right balance. It is equally important to not place materials into the pile that can have an adverse effect. Meat and dairy items will attract pests, such as raccoons. Oil-based items are difficult for microbes to decompose and will slow down the decomposition process. Weed seeds, plant diseases, and diseases carried by meat-eating animals may not be killed, but if the hot composting process is not complete, and therefore are not recommended to be put into a composting system. Manure from grass-fed animals such as cows, horses, and goats do not carry parasites that can transfer to humans and therefore are a good source of nitrogen for a compost pile. To find a source of manure close to you, go to the University of Illinois manure website and list yourself as wanting compost manure. Produce farms have a lot of culls and other discarded fruits and vegetables. These will compost very well. However, there are some concerns. This produce tends to be high in moisture, and therefore dry, high water-absorbing materials should be matched with it to avoid polluting leachate from running away from the pile. Some fruit and vegetables also have hard, thick shells or rinds that take a long time to break down. If possible, these should be chopped around before placing them into the pile. Piles high in food tend to have odor problems due to poor aeration, since materials are so wet. Turning the pile more often is important. Large-scale grinders are available for large composting systems. Old, bad round bales provide a cheap source of dry materials. To build a pile, simply add materials into the pile, inoculate the pile with microbes by adding some soil. If the organic materials are high in carbon, you may need to add some nitrogen as a fertilizer source or manure to create the right C/N ratio. If everything is right, the pile should heat up within a couple of hours. The secret of composting is that once you have a pile created and everything appears to be working well, let it compost. Don't add anything else, or it won't finish composting. Let the pile finish composting is important so that the final carbon-nitrogen ratio is between 20:1 and 30:1 CN. If the final compost is not finished, the CN ratio can actually cause a removal of the nitrogen from the soil, causing plants to be deficient in nitrogen. The pH of the compost pile is affected most by the organic materials used within the pile. The pH of the compost is generally not a concern unless acidic materials such as pine needles are used. A simple pH test kit can be used to check the pH, and lime can be added if needed to keep the pH in the range of a neutral 6 to 7 pH range. Moisture content is critical for composting to occur. The microbes must live in water, and therefore keeping the pile moist is critical. Not too wet, not dry, moist. The optimum moisture content is between 46 and 65% moisture. That's approximately the feel of a wet sponge. Moisture meters or even oven tests can be used in order to monitor the moisture content. If the pile is too dry, add water. If the pile is too wet, there may not be enough air in the compost for the microbes, so the pile should be turned. Microbes and other insects and animals need air to live. The air content of a pile is difficult to measure without sophisticated tools. Oxygen content should be maintained between 10 and 16%. The pile does naturally create a convection force drawing cool air through it as the pile heats up and hot air rises out of the top of the pile. Therefore, focusing on things like the right bulk density of the materials and turning the pile will usually maintain the right amount of air in the pile. The temperature of this pile tells you that everything is going well within the pile. When bacteria are multiplying and decomposing the organic materials, they create a lot of heat. Therefore, the center of the pile tends to be between 130 and 150 degrees Fahrenheit. These temperatures indicate that you have a hot compost system and that the pathogens and weed seeds are being killed. When the bacteria run out of food, their numbers decrease, and so does the temperature. When the pile cools down below 130 degrees, it's a sign that it's time to turn the pile, and this gives more food to the microbes, and it should heat right back up. Excessive heat above 160 degrees can actually kill off the microbes that you want for decomposition, and so therefore, again, the pile should be turned. The hot composting system is doing well if the pile goes through numerous heating and cooling cycles as you turn the pile. At some point, most of the fresh organic materials will have gone through the first level of decomposition, and the bacteria will run out of the easily decomposable materials. If you turn the pile and it does not heat up, the pile is probably ready for the curing phase of composting. Curing means the pile is allowed to sit and only be turned if it gets too wet from something like a rainstorm. During this time, other organisms, such as the fungi, take over, transforming some of the toxic elements into non-toxic items and helping to create aggregates, such that the finished compost will look very much like soil. To have confidence the compost is finished, you can use a Solivita test. These are rather expensive tests, but very easy to use, and will let you know that the toxic chemicals have been decomposed. You can also plant some cucumber seeds in the compost. If they grow, the compost is ready. Compost can be used in many ways around the farm. In this presentation, I've tried to convince you that composting is not that difficult, but it can take time. And if you don't have time and you'd like to purchase compost, there are many places in Illinois to get quality compost. The Composting Council maintains a map and directions to the various composting facilities where you can purchase large amounts of compost. They can also provide you with the analysis of the compost that you are purchasing. It is tempting to take advantage of free sources of compost, but realize that not all sources are really compost. Compost, as you know, now has quite a number of specifications in order to get good quality compost. Compost available from a farm such as this or a stable does not guarantee that it was composted properly. Please make sure that you check and ask them for the records to make sure that it was turned properly and that the analysis is available. If you've taken the time to create quality compost, don't let it be recontaminated afterwards. Use a tarp to keep the weed seeds out. and place it away from runoff sources of possible pollutants. Compost is an excellent soil amendment for produce fields or orchards. Currently, the Good Agricultural Practices, or GAPS, recommendations are being reconsidered. By fall of 2015, new guidelines should be available for use of both manure and compost in produce fields. There are usually minimal restrictions on using quality compost in production soil fields or orchards. There are restrictions on using manure or compost teas. The safety of compost tea depends on the compost used and the method of viewing. If done wrong, it can actually encourage pathogens. It is beyond the scope of this presentation to discuss this. Should you decide to use compost tea, do your research to make sure it's done in a safe manner. The Composting Council does have a Seal of Testing Assurance program, which many large-scale composters participate in, and they should be able to provide you this type of analysis. If you are creating your own compost, you can also do your own testing. This website also provides a list of labs that you can have your compost tested at. If you're going to have your compost tested, call the lab first to determine how to send the sample. The cost of composting can be expensive, with simple nutrient tests running about $30 and a complete analysis including pathogen testing up in the hundreds of dollars. Most compost is not high in nutrient content. Most of the benefits are from this organic material that is added to the soil. This is a typical analysis of compost. Compost made from manures tend to be a bit higher in nitrogen content and other nutrients than a compost that is primarily from plant-based organic materials. Because the compost must be further decomposed within the soil system to release nutrients, this must be taken into consideration in the soil fertility planning for your fields. In general, it is assumed that 10 to 25% of the nitrogen will be available in the first year that the compost has been added. This will change depending on the climate and soil conditions. The article listed below is a good discussion on how to interpret compost additions to soils. A general recommendation is to apply 2 inches of compost each year. That equates to about 150 tons of compost per acre. To not recontaminate compost, make certain equipment used to apply it are clean. Record keeping is important to recognize the benefits of compost to your soil management plan. Keep records of when and how it is to be used, on everything from the amount applied to the weather conditions when you are applying it. It may be possible to make some money by selling the compost you create, but be very careful in doing so. It can impact your necessity to have a permit, so check with the county and Illinois EPA before doing this. Be careful of the benefits that you put on the advertisement to make certain that the compost does not fall into the categories of a fertilizer or soil amendment, which are both registered products in Illinois. Composting is an outstanding soil amendment, and all soils can benefit from adding it. Produce farms create a lot of organic materials that can be easily composted, but it is important to know the rules and regulations that may apply to your situation before getting started. Hot composting creates the best compost, but it requires close attention to several key factors. There are numerous methods of composting. I hope you can find one that fits your farming system so that you can create excellent soil amendments to improve your soil. The rest of these slides are various resources that can help you in your composting adventures.